All right, example 6. I am reading from page 62, mixtures and concentration. These kinds of problems tend to confuse people for some reason. So here we go. It's on page 62, example 6. A manufacturer of soft drinks advertises their orange soda as naturally flavored, although it really only contains 5% orange juice. Shame on them. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to the already 900 gallons of orange soda he has in order to conform to the new regulation? So do you understand what's happening? Yes. Person has 900 gallons of 5% juice, right? To that, they want to add some amount of 100% juice in hopes that the 100% concentration will weaken or increase, the 5%, right? So at the end you have 10%. All right, so it's asking how much pure orange juice. Pure means 100% orange juice. How can we write that? Do we know how many gallons of that we need?
Yes.
We do?
No.
It says how many
Gallons.
gallons of 100% orange juice, right?
Yeah. Gallons.
So, do we know how much?
No.
And when we don't know how much, we
Variable.
assign a variable. So, we're going to say that X is the 100% OJ.
All right.
Okay, in gallons. 100%. Now, this is what's weird, okay? If I say 5%, I think you all know that that's 0.05. For some reason, you guys forget that 100% is 1. So we're going to say 1x, which means 100% times how many gallons that is, which we don't know yet. And we're going to add that to a 5% of how many gallons? How many gallons does he already have? 900. In the hopes that at the end of the day, he's going to end up with a 10% solution, 0.1 times x plus 900. Notice that I have the same setup each time. I have the concentration times the amount of gallons. Concentration, amount of gallons, concentration, amount of gallons. Right? So concentration 100%, that's a 1. Concentration 5%, 0.05. Concentration 10%, 0.1. Here we have amount is x, we don't know. Amount is 900, we're adding it together, so we expect that at the end we're going to have more than 900 gallons, right? We're going to have 900 gallons plus whatever we added. So 900 plus x. Hi Nolan, bye Nolan. So there we go. Now can we solve this? Probably fairly easily. All right, what is 900 times 0.05? Do you have a calculator?
45.
It's on a bookshelf in a second.
Oh!
Right? I believe it is 45, and then so 10% of 900 is 90. Right, so we want to combine our like terms, so we're going to move 0.1x, 0.1x, move this 45 to the other side. So what's x minus 0.1?
X minus
1 minus 0.1 is
0.9 x is equal to.
and if we divide 45 by 0.9,
You get 0.5.
50?
Never mind. No, you only get 5 back.
5?
No, 50.
50. Yeah.
Why am I not even trusting myself? Just 50. So you got 50 gallons of how much? What was X again? The amount of 100%. So we have to add 50 gallons of 100% OJ to an already existing 900 gallons of 5% OJ to end up with 950 gallons of 10% orange soda. Not even OJ, orange soda. It's not even OJ. Right? Mind blown, right? Are we good with that? Okay, awesome. So now we're gonna do example 7. I'll let you finish writing that down. I see people are still writing. Pens are moving, pens are moving. Moving pens, moving pens. Golden rainbows of living color. Are we good? Okay. Ejemplo 7. Set. Every now and then I speak French. Set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. All right. Now we are on to page 63. And this little guy, I know is going to put your little brains in a little twister, but it's actually fairly easy to solve. Because Brandon keeps talking, that is not why. Brandon, you're sitting at a table of facts. You're going to have to expect to get picked on, okay? It's just going to happen. I mean, yours truly is, you know, that word that he said. So, you know, it's just going to have to happen. Here we go. Because of an anticipated heavy rainstorm, which we never see around here, the water level in a reservoir must be lowered by 1 feet. Because if they don't lower it, what's going to happen? Overflow. Okay, so they need to lower it. Opening spillway A. So they have 2 spillways. We have a spillway A and a spillway B. That's how the water is going to get out. Okay? Spillway A, spillway B. And it says, if you open spillway A, it lowers the level by this amount in 4 hours. So what fraction of the time will it take to do that if you're doing it by hours? It takes 4 hours. Okay, we'll get back to that. Let's keep reading. It says, whereas opening the smaller spillway, B, does the same job in 6 hours. So you have this job that needs to be done. Okay, one of the spillways will do the job in 4 hours. One of the spillways will do the job in 6 hours. So clearly one of them is faster than the other. 6 hours is more time, so therefore it's slower, right? So what they're trying to ask us is, well, what would happen if we combined them both at the same time? Like how long would it take if they were both working at the same time? Because one's faster and one's slower. Would it be 8 hours? Would it double? Would it be 12 hours? I mean, what would it be? Hopefully not either one of those. It would be a combination of the two, right? So that's what we're saying. So what we want to do is for our variable, we actually want to say that x represents the time for the job to be done, for job to be completed. In this case, the job is lowering the reservoir by 1 foot. That's the job. But in your homework, I mean, the job could be a lot of different things. The point is here that you want to look for the pattern. They've got 2 options, and one option takes longer than the other, and they'll tell you how much time each option takes. So we're going to say that x is the time for the job to be completed. So that means that spillway A will do 1/4 of the job because it takes 4 hours. How long does it take spillway B? 1/6 because it takes 6 hours. So it'll be a fraction of the time. But we want to see if they work together, what will happen? 1x. We don't know what that x is going to be right now. What is the job time? And that's pretty much all you have to do. Well, you have to solve it, but that's how you set it up. The first spillway would do 1/4 of the job. The second one would do 1/6 of the job. And you want to know what that total job is going to be. All right, so now to solve it, this is your equation. How do we solve it? Any ideas? Angie? Okay, which would be? 12x. So times 12x times 12x times 12x. What's going to happen here is you're going to get 12 divided by 4 is 3. 3 times x 3x. Here you get 12 divided by 6.
2.
2x. And here the x's will cancel and you get 12. 3x plus 2x equals 12. Right? So you get 5x equals 12. Divide by single. And x equals 12 fifths of an hour. That's basically what it's saying, right? So what is 12 fifths? 5 was to 12, 2 times. And has a remainder of 2, right?
2.4.
That's 2 hours. What's 2 fifths of an hour? So 2 hours and 24 minutes. So using spillway A, we'll do it in 4 hours. Spillway B, 6, but if you combine them both, 2 hours and 24 minutes. Now that's the way to go. So that is your example 6 and 7. So for the rest of the